Hello and welcome to my video on Kirchhoff's voltage law and AC circuits. Kirchhoff's voltage law states that the summation of all the voltage drops across a circuit is equal to 0. Here is a simple DC circuit in which the source voltage is equal to 10 volts, V1 equals 4 volts, V2 equals 3 volts, and V3 is a value that needs to be found. A simple application of KVL gives us this formula, which can easily be simplified and solved for V3. We are lucky in that KVL in DC is very similar to KVL in AC, and that AC also states that the summation of all the voltage drops in a circuit is equal to 0. The difference is that AC voltage is represented by a sine wave, in which the instantaneous voltage is given by this formula here. Vp, or the peak voltage, is the amplitude of this wave. Omega is a value that is constant in each circuit and is related to frequency, and theta is the phase shift. Problem arises when we try to use Vp in our formulas, as it cannot be used, so we need to use the vector Vrms, which has an angle of theta attached to it. Vrms can be found using the formula Vp over root 2. This means that while the application of KVL in DC looks like this, the application in AC is very similar, but with an angle attached to each voltage value. A problem arises, though, when we try to add or subtract these vectors, as it is very difficult to add or subtract vectors in polar form. This means we need to make the conversion from polar form to rectangular form, so that the formula previously used will look like this. This makes it a lot easier to add or subtract these voltage values. This conversion is done using formulas. The formulas to convert from polar to rectangular are shown here. The formulas to convert from rectangular to polar are shown here. Here is a simple AC circuit in which the source voltage is equal to 10 volts at an angle of 45 degrees. V1 is equal to 4 volts at an angle of 0 degrees. V2 is equal to 3 volts at an angle of negative 45 degrees, and V3 is the value that needs to be found. The application of KVL is very similar to the last video, but then when it gets to this step, we need to use the vectors instead. These will be converted to rectangular form and then added or subtracted to get the final value for V3. This value then needs to be converted back into polar form to have the final answer for V3. Thank you for watching this video.